So looking at midstream GIS and really looking at pipelines, you want to consider pipelines in the progression of their workflow. So you might start where you are actually trying to get the land to bring the pipeline across. Sometimes you have a main line that you're dealing with or a gathering line. And here you can see more of a main line coming across, and we've got some shut-off valves for this main line. Well marked here along the fence line, you can see where it's at. And what they want to try to do is to get permission to put these pipelines across this land. This requires you to do a lot of land title work, easements, to get just access to come out here to survey where you want to put the pipeline becomes important, and you will want to know who the landowner is, and he might be an absentee landowner. He's not actually out here. So you've got to contact him somehow and keep up with those who you have contacted. You have to go through and have you sent them a letter? Have you gotten written permission to get out onto their property? Just because you have, for example, the rights to try to get to your oil and gas as a dominant holder of the estate as a mineral owner doesn't mean necessarily that you're going to have the rights to get out on the property for a pipeline. So going through that process and using a GIS to have that cleared and understood is very important, and you can share that with others so that they can see where you are with the land process. Now, as you're going to design the pipeline and look at where you're going to try to put it in the best locations that you can to make it inexpensive. Sometimes these are small gathering lines that could be 2 inches, 4 inches. I've seen 1 inch gathering lines for very small gas type systems. And you're going to need to work on building a GIS that helps them to find the best route. Now, the best route, you have a lot of topology. You know, you're going to be going over roads, for example. Here we have to go over a road. We don't want to have to tear up the road, so you're going to bore under the road. So you might start back here and go towards a area where you've got, you know, these cutoff valves, and go under the road, and maybe you'll come back out on the other side of the road, and you can see here we'll have some more shutoff valves. But you'll also things that you see like here, like cathodic protection. Now, on a cathodic protection, what that's to do is to put a small voltage onto the pipeline so that you can reduce the amount of corrosion that you might have on the pipeline. So this small electric charge has a constant ability to deflect any corrosion that could occur. Now, when you're designing the pipeline and keeping up with it, there's a lot of attributes that you keep up with all the valves, with all the T's, vents, other things that are connected to midstream type pipelines that get put into the attribute information. And typically we take those off the design drawing. So if you need to get those, it's important to look at gathering that stuff either from the existing design drawings or gathering it from historical documents and information that you might have. Now, when these pipelines reach a central location, they get to a gathering point, could be a compression station that's bringing in lots of different areas, compressing that gas and moving it forward. So then we're going to move to a facilities GIS, where we might maintain the information of the facilities for that pipeline, that midstream work. Now, I've designed several different pipelines, stamped them as work that I've done for companies. And in doing so, the key things that they've asked me to do is obviously avoid environmental sensitive areas. You don't want to go through swamps or wetlands or streams or high areas of population. So you want to try to avoid those. And then when you're keeping up with what you have to do for the Federal Department of Transportation on these pipelines, you need to have all this information ready at hand at any time in case there's an incident. Having pipelines, knowing where they're at, their true location, where they design it at and where they put it at might change. Sometimes when they're going down through here, and we'll do a design, we'll get it all figured out that we're going down this corridor that you see back here, and coming across the street here to this other corridor. You might slightly change the design based on, you might hit a big rock, you might hit a sensitive area that you have to avoid. So in the field, they'll make those changes, and you might not get those if you're using the design plans as your way to build the GIS. So having someone that could map it as you go along. One of the things that I did is I got some of my pipeline people to get drones actually, and to fly the drones over when the pipe's being open and shown there in a trench, because we can't send a surveyor over time with a centimeter level shot to get everything. But when we can see the open pit or where the drone is, I'll then set targets and have them fly over the drones. I'll send my surveyors back to shoot the targets, because a lot of times when they're trenching the pipe, they want to instantly cover it back up so we don't have any hazards of somebody falling in and getting hurt and so forth. So you might miss that opportunity to get that as-built information for the pipeline that it's exposed. Key things about pipelines: when they cross waterways, you have to bore, but some are just barely on the water. I've had to do hydrographic surveying. I've done pipeline locations, the RD 8000, one of the radio detection units that can locate it. Basically what you do is you connect a magnetic signature to it. It's charged like a magnet. You have a magnet, you push two magnets together. They want to show push apart. And so you can use that magnet pushing apart or resistance to calculate how far this magnet is from that magnet, and we use that to do depths. Then you'll see them go through and they will actually search for the pipe using a rod and do probing, and which is more accurate, and then you can come back and shoot the probing portion. Always with pipelines and GIS and information that you have for this, it is sometimes worse to have a general idea than no idea, because if the general idea is too far out, people might dig. People might go in and try to think that the pipeline's located where it is not. So you want to be careful about how you represent that, or at least have attributes that tell you the accuracy of the midstream. These are gathering and main lines. When we start talking about public lines inside of subdivisions, natural gas lines giving it to the public, those are a little bit different, but still they're carrying the natural gas product to them. Information all stored in that GIS can be very helpful.
For the offshore industry, pipelines are tied and managed in the Seabed Survey Data Model. The International Association of Oil and Gas Producers, OGP, published the Seabed Survey Data Model, SSDM, version 1 in April 2011. The SSDM is now the Seabed Survey Data Model de facto industry standard for the delivery of seabed survey data for geese. The OGP SSDM is applied for hydrographic and geophysical seabed surveys such as platform and drilling hazard site surveys, pipeline route surveys, pipeline prelay and inspection surveys, debris surveys, bathymetric and other types of seabed surveys using side-scan sonar, SSS, single beam and multi-beam echo sounder, MBES, and single and multi-channel high-resolution seismic. The data model does not include or cover the ROV-based video pipeline as built and inspection surveys. The majority of data from pipeline ROV surveys are pertinent to pipeline data models, for example field joints, anodes, free spans, pipeline burial, with the exception of seabed data like bathymetry and seabed features acquired and mapped with bathymetry and sonar sensors on ROVs. Operators have expressed a need for being able to integrate the seabed survey data stored in the SSDM format, for example bathymetry, survey metadata, seabed features, shallow geohazards, with pipeline infrastructure and raw data, for example inspection, as-built events, that are stored in pipeline data models. The interface between pipeline data models and the SSDM will allow the integration of the sweep, site, environmental and geotechnical survey data with the associated pipeline infrastructure. The development of this guidance was based on close cooperation between the OGP Geomatics Committee SSDM Task Force and the PODS Organization and APDM Technical Committee. Pipeline Open Data Standard Relational, PODS Relational, Pipeline Open Data Standard ESRI Spatial, PODS Spatial, and the ArcGIS Pipeline Data Model, APDM, are data models used to manage geospatial pipeline GIS data. PODS and APDM are based on the linear referencing concept and are entity relationship intensive data models. Linear referencing is the method of storing geographic locations based on relative positions along a measured line using distance or temporal measures, like kilometers or hours. PODS is a recognized industry standard that defines a comprehensive feature dataset to describe pipeline systems including assets, inspections, maintenance, cathodic protection, operations, attached and offline features, risk analysis, and geographic location. The PODS standard was developed in 1998 to help pipeline companies comply with integrity management (IM) regulations in the U.S. Today, it is estimated that approximately 530,000 miles of regulated pipelines in the U.S. are managed by PODS member companies utilizing this standard. Outside the U.S., statistics on PODS usage are more difficult to ascertain. Approximately 30% of PODS members' companies are located outside the U.S. PODS and APDM are applicable within an offshore context and are capable of managing umbilical and subsea architecture data. However, there are no official statistics available on onshore versus offshore use of pipeline data models. There are 4 data types found in PODS and APDM centerline data. The pipeline centerline is geometric with a built-in measure or distance system. PODS relational stores coordinate information for the centerline features. PODS spatial and APDM stores an actual geometric object within an ESRI geodatabase as a point, control points, and a polyline station series, representing the spatial location of the pipeline route. Online, linear, event data, tables/features with attributes that locate events or features on a route or pipeline, utilizing the relative station or measure, thus indicating geographic position, valves, coating, subsea spans, etc. Offline data, purely geometric features, points, lines, polygons, representing things close to or surrounding the pipeline. PODS relational stores coordinate information and or bearing/distance for offline features within attributes. The coordinate information in PODS relational is not compulsory. Tabular data, tables with attributes that contain no spatial component, but are associated to pipeline features, like owner/operator contact details, readings, external documents, etc. These data elements are organized into several submodules based on the function of the associated data. The station centerline module is common between PODS and APDM and represents the core pipeline information that forms the foundation for the whole PODS/APDM model. All other tables in the models are linked either directly or indirectly to these core tables. This is the module that will be the focus of integration with the SSDM. The following core elements are common between PODS relational, PODS spatial and APDM: pipeline centerline/hierarchy management, document storage, report/activity management, site/facility management.
Okay, so let's talk about pipeline right-of-ways. So when you drill for oil and gas, here you can see behind me a oil well that's got an artificial lift right there, pump jack that's bringing the oil and the gas, natural gas, up to the surface. The pump jack then will have the oil maybe come over here to the tanks. The tanks, they come by and drain using a vacuum truck from time to time, but the natural gas is instantly put into pipelines. And we can see over here a series of pipelines that are for the natural gas system. We have several things that could be doing: compressing, adding liquids, separating liquids from the pipelines. We can see over here on this area right here, you can see a solar panel and a radio tower This is probably a SCADA system that's communicating back somewhere and telling them the natural gas flow that's coming out. That data is probably inside of a GIS or somebody that's monitoring that information. This is considered the point of sales, and actually what they're doing is they also have to measure how much natural gas is coming out of the ground, and we keep up with that so that we can pay our mineral owners or royalties to our leaseholders or royalties to those who gave us rights to drill on the property. But to get the pipelines across there, you get a right-of-way. And that right-of-way is called an ingress and egress, an entrance and an exit. And specifically, those right-of-ways through time historically have gotten more and more complex because they have to define specific rights. Not just the rights to enter and exit, they might have that you can actually mow the grass, that you can maintain, that you can keep up your gates, you can keep things clear and set up. Older right-of-ways might not have fully explained rights, and landowners who have purchased land from somebody that's been encumbered with the pipeline notice these people coming out on their property, and then they go, well, hey, I want to get reimbursed for them. So they've questioned historical right-of-way that individuals have. So the information that you maintain in a GIS for the right-of-ways become important because those are agreements that the current landowner and every landowner after that must keep up. When you do a title search and you buy a piece of property, you'll see that they're encumbered with these right-of-ways. And sometimes people had said, hey, okay, you have a right to come and go into my property, with some kind of a fence mechanism, but maybe I don't give you the right to bring electricity across the property. So if you didn't give me the rights to bring electricity, I might have problems with trying to bring power out to some of my sites where I need electricity. Sometimes they don't have their own power source. You can see that's why we have some of the solar panels back there in the back. You can see a larger solar panel that is actually there from that standpoint. And those go on to be used to try to give power to do certain things that we need out here. So you need to know all these informations. So you need to know all this information so that you can have an understanding of what rights you have when you come out here to work on these pipelines and their right-of-ways.